All right, you're welcome to another class, a statistics class again. And this time around, we want to continue from where we stopped from our last class. In our last start, we started with the uh, test of difference. And we started looking at the first tools, statistical tools that were called chi-square. If you look at it yesterday, we already deal with those one that has just only the observer value, just one variable. So this time around, we want to look at, we want to compare expected and then observe frequency, which is going to serve as a second example. But before we look into that, I want us to quickly look at these questions on my screen. If you see the questions on the screen, you will see that the question is talking about the contingency table. If you look at it, it's really talking about the contingency table. And this question you are seeing here is referring to a research fellow or researchers, a set of researchers who want to investigate, to look at the relationship between genders and the sales of one drink on another in a locality. So they want to look at it in this way. So in the findings, they have already done their findings, and they are working on 4 products. The first product is Coca-Cola, the second one is 7-Up, the third one is Martina, and the fourth one is Fanta. And when we look at it, the male for Coca-Cola is 5, for female is 5 as well. For 7-Up, male is 46, female is 34. For Martina, male is 32, female is 18, and the light. So what exactly did they want to do that? They have to set up, like I told you in our previous video, where we talk about hypothesis. We define, we said basically there are 2 types of hypothesis. When you set a null hypothesis, you just have to look for alternative hypothesis, that if the null hypothesis is not working, you have to think of selecting this other option, which is the alternative hypothesis. So for these two, we want to quickly set up an hypothesis for this. So, and of course, like I always say, that when you want to set an hypothesis, you need to set the null hypothesis, which is always in negative. So for this now, to test this hypothesis of independence between the genders and then the consumption of this drink using this chi-square, the non-hypothesis will be the types of consumption of this drink does not depend on the gender. That is, the types of this consumption of this drink does not depend on this gender. That is the non-hypothesis. And if you are talking about the alternative hypothesis, it means, since we said does not, so that means the alternative hypothesis means what? There is, there should be. So that is that about the non-hypothesis and the alternative hypothesis. So before you do anything at all on this table, if you look at this table now, of course we know the formula for our chi-square is always summation observe minus what? Expected all square, everything divided by what? The observe. So I want to quickly explain this formula one by one, so that you will see that all the elements that will have inside the formula are well defined. And I want us to pay attention on the screen as I'll be defining this one after the other. And I'll also talk about the procedure to follow when you are doing this. So when you actually look at the formula, you will see that the observe minus expected, that is, the O is representing the observe, while the letter that look like E is representing the word, the expected, and the summation sign before this is really talking about the addition. For the previous video, you see that one is just dealing with 1. And of course, before you can get this, you need to look for your expected frequency, because when you look at all the variables, all the figures that this researcher is putting here, they are all observed value. So therefore, there is need for you to get the expected value. So when we get there, we'll talk about the expected value. So, but I want us to quickly look at these one after the other, and the procedure that you need to follow as a researcher. Of course, like I said, the first procedure to follow here, in working on the contingency table is that you need to first of all look for find the numbers of the row total, the row totals and the what and the column total, the row total and the column total. How many rows do we have here? Do we even really know what is the difference between a rows and a column? And that's the most important thing, because you need to get what is the meaning of a row, what is the meaning of a column. When we look at this now, you will see that the row for this is just 2 rows. That is talking about the male and female. Let me show us this. It's just talking about the male and female. That is the row. This is 1 and the what and 2. So that means our row is equals our R, which is the row, is equals 2, and our column is what? 1. That means we are talking about 4 products. 1, 2, 3, 4, and our column is equals 4. So by the time we want to get our degree of freedom, which will come back later, the degree of freedom says the row minus 1 into column minus what? Minus 1. The row here is just 2 minus 1 into 4 minus 1. 2 minus 1 will give me 1, and 4 minus 1 will give me 3. So that means the degree of freedom is just what? It's just 3. That is how to find the degree of freedom. So, but we don't need this. So that means I'm just telling us the procedure. The first procedure is to what? Is to first of all look for the what? For the row total and the what? And the column total. But I just told us now that when you look for the row, this is the row total for this, which is what? Which is 90. And for the second row is what? Is 40. And for the column total, when we look at for the Coca-Cola, is just what? 5 plus 5, which is 10. For the 7-Up is 80. For Martina is 50. For Fanta is just what? Is just 10. So that is what we mean by the word. You have to identify the word, the row total, and the what? And the column total. And of course, I've just used that to talk about when we want to look for the degree of freedom. So the second step is to determine the expected frequency per cell. You need to determine the expected frequency by what? Per cell. Determine the expected frequency per what? Per cell. So that means all these we see here, because this is just a question, all these are just expected value. Sorry, they are just observed value. So there is need for you to get an expected value for this. This is an observed value. You need to get expected value. This is observed. You need to get expected value, observe, and get what? Expected value. So therefore, I can just divide this, that all these are observed value, and we need to get the expected value. So the second step, I can also get, of course, all these are also observed value. So I can get the expected value as well. So when we look at it, that all these are just what? They are just observed value, and we need to get the expected value. So that is the second step. So can we quickly go on with the second step? If you want to go on with the second step, for you to get the expected frequency, there is a formula you use. For you to get the expected frequency, the formula for expected frequency is C, which is equals to expected frequency, which is C, which is equals to R, C, everything divided by what? By T. What does that R mean? This is a small letter, this is a small letter C, and this is a capital letter what? Capital letter C. So what does that R mean? The R mean the row total. The row total. The row total. What is the row total here? You can see it is what? It is 10. Multiply by column total. Row total multiply by column total. The row total here is what? Is 90. Can we see that? And the column total here is what? 10. So that is 90 multiplied by 10 divided by the grand total. So the grand total, which is equal to what? 150. So that is how to get your what? Your expected frequency. So if I calculate this one now, okay, let me say this one is just for this one is for Coca-Cola, which is the first one. This one is for Coca-Cola. Okay, so if I move on to 7-Up, the expected if I move on to the expected frequency for 7-Up will just be what? Again, row multiplied by column over what? The row total multiplied by column total. So what is the row total here? The row total for here, don't forget, this is what? 90 multiplied by, for 7 up, that will be 80 divided by what? 150. So I move on to the third one, which is what? Mortina. I love Mortina because I'm an ambassador for Mortina, and I'm proud to be. All right, so let's go into that. So for the column total as well, we have row total multiplied by column total divided by what? The total. So that is 90 multiplied by 50. Everything divided by 150. So the last one, which is what? Fanta. So for the Fanta 2, that will be equals to, the total here is what? Is 90 multiplied by 10. Everything multiplied by what? 150. So if I come here now, what's the total for this place? So that'll be this one multiply, everything will give me 6. So that is 90 multiplied by 10 divided by 150. When you divide it, it will give you 6. So when 90 multiplied by 80 divided by 150, that will give me 48. Ditto to these two, 90 multiplied by 50. When I divide it, that will give me what? 30. If I move on to this one, this divided by this, of course, this will give me, what is this going to give me? I want you to confirm this at home too. I want those of us at home to also confirm it along with me. Confirm the calculation along with me. So those of us joining me at home, can you confirm the calculation with me? So confirm the calculation with me. I want us to do it together so that it won't look as if, oh, it's just copying this. So we want to look at the expected value now. So when we come here now, like I said, 90 multiplied by 10, that will give us 900. 900 divided by 150, that will give me 6. You can see that 90 multiplied by 80, that will give me 7,000 divided by 150. 7,200 divided by, so that will give me 48. So if I move on to the third one, that's 90 multiplied by 50 divided by 150. Of course, that will give me 30. So the last one, 90 multiplied by 10, which is 900. And when you divide that one by 150, that will give us what? 6 as well. So when we look at this now, you will see that I have got the expected frequency. I've got expected frequency for the male. I've got expected frequency for the male. So that means expected frequency for this one is just 6. Expected frequency for this, for 7 up, is 48. Expected frequency for Mortina is 30. Expected frequency for Fanta is just what? Is just 6. And of course, I can get expected frequency for this. Of course, what do you think that will give you? It will give you 90. Because that will just be 90 multiplied by this place. That will just be 90 multiplied by what? Multiplied by that, and everything will as well give you what? 90. So there is no point in stopping yourself. Now, what you have just done for the male, which is the first row, you are going to do the same thing for female. Of course, at our elementary level, we normally call a question a word problem. Where they said, I think of a number and I add 3 to the number and the result is 5. What is the number? Of course, since you know one number is 3 and they said the result is 5, so that means the number is just 2. Okay, so if that should be the case now, if they said the expected value, expected frequency for Coca-Cola for male is 6, and of course you know the total numbers of the whole Coca-Cola is 10. So definitely you don't need to stress yourself. Expected value for this one too will just be what? It will just be 4. And if you want to confirm that, this is how to confirm that. For female, this will just be 60 multiplied by 10. 60 multiplied by 10 divided by 150. That's just 4. So instead of you going through this process again, it's just for you to do a kind of addition and subtraction. And of course, when you add this, that will give us what? 10. So when I come to this as well, this is just taking 48 away from 80. And that will give me 30 what? 32. And the total here will be what? 80. So for this one is just 50. This will just be what? 20. because if I add this one together, it will give me what? 50. So for this one too, it's just 10. So if I take 6 away from 10, that will give me what? 4. And if I add everything together, it will give me what? 10. Or except if you want to show over sabi, what people used to call over sabi, you can start passing through this process for female again. Of course, with this, you are good to go with everything you have done there. So with this now, we have got the expected frequency for what you have here now. So I want to move on to the chi-square table. So you are going to permit me to clean all this since I know my formula offhand. So there is no point disturbing myself. Let me permit me to clean this as well. Permit me to clean this. If you are just joining us, you're welcome to our statistics class. So permit me to clean this as well. So I'm going to put the formula here. But before I will do that, before I'm going to do putting the formula here now, you see that the chi-square s square, this is the symbol for chi-square, simply means summation observed minus expected all square, everything divided by what? Expected. Everything divided by expected. So I want to construct the table. Some scholars believe in taking this one by one, but with my own experience as a statistician and also a mathematician, I felt there is need for us to follow this table. If you follow the table, it will be very easy for us. So I can follow the table. This is just four items, 1, 2, 3, and what? And 4. So I can say serial number, call this my serial number. So we should just be 1, 2, 3, and what? And 4. And don't forget, this may look like a 4 alone, but it's going to be bigger than that because it's going to be times 2. You know, it is for male and what? And female. So it will go to what? To 8. So the next thing now is for me to get my observed value. So don't worry, this will be 5, 6, 7, and what? And 8. Why is it 7 and 8? Because we have male and what? And female. So observed value now, observed value for all these, then I will get my what? Expected what? Value. So what are my observed value? For male, that is 5. For male, 5, 46, 32, and what? 7. For female, 5, don't forget, 34, 18, and what? And 3. So let me just confirm that is 5, 46, 32, 7, 5, 34, 18, and what? And 3. So those are my observed value. So when I get my expected frequency, what did I get? Where I got 5, the expected value is what? Is 6. Where I got 46, the expected value is what? 48. I'm just bringing what I have on this table into this place. So there's nothing like that is difficult there. So when we move on now, for 32, the expected value is 30. When I got 7, the expected value is what? 6. When the observed value is 5, the expected value is just what? 4. When I got observed value is 34, the expected value is what? Is 32. All right. When I got the observed value as 18, the expected value is just what? Is just 20. When I got observed value as 3, the expected value is just what? Is just 4. So what have I done now? I've just got my expected frequency. And don't forget, like I said, there are procedure. I've just talked about the procedure to get the expected value. So the next step now is to find the difference between the observed and expected value. So that means we have got our observed value and we have got our expected value. So the next thing now is to find the difference between the two of them. So when you are finding the difference between observed minus what? Expected value. The difference between this and this is just what? Minus 1. Difference between this and this, minus 2. Difference between this and this is just 2. Difference between this and 1. Difference 1. Difference between these 2. Difference between this minus 2. Difference between this minus 1. Can you confirm that? Can you confirm that for those that are joining us? Okay, great. Can you confirm that on comments? I want to see your comments if you are really with us. If you are really with us. Okay, all right. I've got someone said confirm. Someone have just said confirm. Okay, so I want you to confirm that. So from there now, since the formula says observed minus expected all square, so that means the next thing to do from here is to get your observed minus what? Expected all square. So we want to square this now. So in squaring this, square minus 1, that is 1. Square 2, that is 4. Square 2, 4, 1, 1, 4, 4, and 1. Now, what's the next thing? We are almost through. So the next thing now is for us to get, don't forget the formula for chi-square says observed minus summation, observed minus expected, all square divided by expected. So that means you still need to take one step forward because this is just a contingency table which is having male and female. If it is 1, you may just ignore, you just know that your expected is your expected. Your expected frequency is your expected frequency. So, but for the sake of this one, you still need to get observed minus expected all square and divide it with what? With the expected. Let me see if that can still show very well. With the expected. Okay, fine. With the expected. Can we see that? So where is your expected value? Your expected value is this. And your observed minus expected all square is just 1. So that means at this point now, this will just be 1 divided by what? 6. I'm picking my expected here. Here will just be 4 divided by 6. Here will just be what? 4 divided by what? Expected here. Sorry, expected here is 48. So that means I'm using this to divide this to divide this. So at this point now, 4 divided by what? 30. This point, 6 divided by what? Expected. Sorry, this will just be what? 1 divided by 7. Here, 1 divided by, don't get it twisted. Okay, I can see your comment, don't worry. This is 4 divided by 30. This is 1 divided by 6, not this 7, because this is just observed. 6. This is 1 divided by 4. This one is 4 divided by 32. This one is 4 divided by 20. This one is what? 1 divided by what? Divided by 4. So can we get the value? We are going to get the value together because I don't want to leave you alone with this. So 1 divided by 6. Okay, let me give you time so that we just go for, you are still there. It's okay. I just want to, oh yeah, so can we calculate that now? Let me see our comments. I can see some people passing comment. Okay, somebody say confirm. Adebayo Omolade, thank you. Adebayo Omolade said confirm. You can try to copy this and share this with others. It will be okay if you are joining me live here and you get it. If you have any question, you can put your question under the comment and I will react to that immediately. So let's see this now. 1 divided by 6. So what is that going to give me? So 1 divided by 6, that will give me, we can put this to 2 decimal. So that will give 1 point, sorry, that becomes 0.167. I put that to 3 decimal places. So 167. 0.167. So the second one, 4 divided by 48. Okay, that's giving 0. That's giving me 0.167. 0.083. 0.083. Let me check if you can see my okay, fine, you can see that. Please, if you can see my last step, can you put confirm in the chat? If you can see my last step, can you put confirm in the chat? Type confirm in the chat. Type confirm in the chat. Type confirm in the chat if you can see my last step there. Okay, so please try. Okay, thank you, Olaniyan Basirat. Try to call attention of others to join this in case if they have any question. Okay, so let's move away from there and move on to 4 divided by 30. Okay, of course that will give me 0.133. So I move on to the next one. Of course, I've got 1 divided by 6 the other time. So that is 0.167. So 1 divided by 7, 1 divided by 4. That's 0.25. Don't forget it's 3 decimals, so you have to put 0 at the back. So next one, 4 divided by 32. So that will be 0.125. 0.125. Of course, 4 divided by 20. 4 divided by 20. We know what 4 divided, so that's 0.0. It will give you 0.2, but don't forget we are taking it to 3 decimal. So the last one, which is 1 divided by 4. 1 to be divided by 4. That will give us as well. That will give us 0.25. So that will give us 0.250. So at the end of the day, the total of all your value here now is what you call the calculated value. When you add this, that's why they call it summation. So this is just summation, observed minus expected, all square divided by expected, which is this now. So when you add everything together, let me give you time to add it together. Add everything together and put your answer in the comments. Add everything together and put your answer in comments. Add everything together and put your answer in comment. But because of our time, I will quickly do that. Let's do it together. Yes, I know you can do it. Those of you online with me, can you add it together and put your answer on the comments? Add it together. That is 0.167 plus 0.083 plus 0.133 plus 0.167 plus 0.250 plus 0.125 plus 0.200 plus 0.250. Can we get the total for me? Good. That is giving me 1.37. If you got it, put it in the comment section. If you are working it with me, of course, don't forget that the essence of working this out is for us to not just to be watching the video. You work it along with me as I'm doing this. You work it along with this with me as I'm doing this. That's the beauty of it. Yes, thank you, Olaniyan Basirat. Thank you, Olaniyan Basirat. Thank you. I'm waiting for Adebayo Omolade to do his own too. Make sure you copy this link direct and share it with others so that they can join us. Okay, so we've got that 0.37. 0.37. So at this junction now, we are done with the calculated value. So we have got the calculated word. We have got the calculated value, which is the fourth step. Which is the fourth step, because the fourth step says you divide by expected value, which we have done here. And the last one now is that look up for table to what? For critical value. For critical value. All right. Like I always tell you, it is very easy. what you just need to do is to, at this point now, we have got our calculated value. We have got our calculated what? Our calculated value. So that means our calculated value is just 1.37. And don't forget, you need to get your degree of freedom. And I said for you to get your degree of freedom for this, it is row minus 1 into column minus 1. How many rows do we have here? How many rows? 1, 2, which is what? 2 minus 1. How many column? 1. That is the product. Coca-Cola, 7-Up, Martina, and Fanta, which is just what? 4 minus 1. When you take 1 away, this is 1. When you take 1 away, this is 3. 1 multiplied by 3, that is what? 3. So that means you need to go to your table, your chi-square table. You go to your chi-square table. This is a chi-square table. If you can see that on camera, if you can lay your hands on any 4-figure table, you get a chi-square table there. So once you get your chi-square table, you are checking at 0.05 as well as 0.01. Of course, I've told us these times without number. In education, what we base our level of significance on is 0.05. It shows when you conduct a test and your student got you have 95% pass. That means the 5% out of 100 is just a minor. It doesn't care for anything. Even if you conduct exam for 100 students and 95 of them pass, nobody can query you that how do you do it in that way? How come the 5 students fail, 5% fail out of these people? So that is why education always stand on what? On 0.05 level of significance. But in medical, you cannot try that. They always place it on 0.01, which is 99%. So they were expected that for every 100 patients they treat, probably 1 should what? Just die. Unlike education, where you have just 95% confidence interval. So for this now, so when you go into your calculated value now, you are checking 0.05. For 0.05 under 3, because your degree of freedom is 3. So 0.05 under 3. Under 3 will give me 7.814. Approximately 7.81 what? 5. Under 0.01. 0.01. That is 11.345. 11.345. So this is under this. This is under 0.05. So that means invariably, when you now compare the two figures together, the calculated value, which is this is calculated, you compare it with the what? With the table value, which you call critical value. Some call it, some textbook call it critical value, some call it table value. I call it table value because we check it on the what? On the 4-figure table, on the statistic table. So the table value is just what? The table value is just 7.815 under 0.05, 11.345 under 0.01. But when you look at these two, you see that the calculated what? The calculated value is 1.375. Is more, is greater, sorry, is lesser than what? Any of these. Is lesser than any of these. So once it is lesser than, once your what? Your calculated what? Your calculated value is lesser than the critical value, you take the non-hypothesis. You take the non-hypothesis. But in case if this one is greater, you take the alternative. And of course, you remember the non-hypothesis is what? Is the negative hypothesis that always say there is no significant difference. There is no significant difference. The alternative is there is. That's the alternative. So that means before you can say there is no, That means your calculated value must be lesser than the what? Table value. Before you can say there is, before you can say there is no, your calculated value must be lesser. But before you can say there is, your calculated value must be greater than what? Critical value. I hope you got that now. So we want to conclude that since our calculated value at 0.05 and 0.01 found on the what? On the table is what? Is greater than the what? The calculated value here is lesser than the what? Than the critical value. Then we conclude that what? Our observed calculated value 1.3 is lesser than any of the what? Any of the critical value. Then we accept the null hypothesis. I will come to take that again. Once the calculated value here, the calculated value, what to calculate on your calculation, the calculated value, once it is lesser than what you go ahead and check on the table, you accept the null hypothesis. But if this is more than what you check on the table, you accept the alternative hypothesis. I hope that is taken. If that is taken, can you type it on the chart? If you get what I'm saying, can you type it on the chart? Thank you, Olaniyan. At what point do we take the null hypothesis? At what point do we take the null hypothesis? Null hypothesis now. At what point do we take null hypothesis? Can we type it? I want you to do it like this. Just do it like this. This is calculated value. If calculated value is less than what? Than the table value, you take the null hypothesis. If calculated what? Calculated value is greater than the table value, you accept the alternative hypothesis. Can you type it if you get it on the chart? So that when you are taking this to do your analysis, you should know what is taken. Okay? Adebayo said it is taken. So that's all. Yes, if the calculated value is lesser than the table value, then what do? If the calculated value is lesser than the table value, do you take null or you take alternative? Yes, you accept the null hypothesis. Thank you, Olaniyan. Thank you, Olaniyan. But if it is greater, you take the alternative hypothesis. So therefore, on conclusion now, we can now conclude that what? That we accept the null hypothesis, that is, the types of the drink they are drinking, the consumptions of the drink does not depend on the what? On the gender. That is what this is explaining. So I'm going to give you a kind of homework, and I will give you an homework, and we meet here same time with my international students. If the local students, if Nigerian students also wish to join me, you can also join us as well. But there will be a class for my international student tomorrow. Tomorrow we'll be looking at t-test. Tomorrow we'll be looking at t-test. We'll be looking at t-test. And next week we'll be looking at analysis of variance. We'll be looking at analysis of variance. So let me quickly look for questions and give you. Let me look for questions. Just a minute for the questions. A minute for this question. I'm actually looking for a question that I can use for chi-square. Just a minute. Just a minute. Okay, if I'm not seeing that, I will definitely put the questions under the comment. So I want to quickly run you through the procedure again. Then thereafter, I will call it a day. The procedure for chi-square under contingency table. The first step is to find the row table, the row total, and the what? And the column total. Find the row column, the row total, the column total, and the grand total. That's the first step. The second step is that you determine the expected frequency per cell. Determine the expected frequency per what? Per cell. The third step, find the difference between observed and expected frequency per cell, and you square that. The fourth step, you divide by expected frequency for each cell and sum up to get your what? Your chi-square. Then the fifth step is to what? Is to look up to the table for critical values of the chi-square for the degree of freedom and required significant level. So this is how far we can go on chi-square. If you really get everything, I want you to put it into the comments. Please, can you be of assistance for SPSS? Yes, somebody is asking, can we be of assistance of SPSS? Yes, of course. The reason why we are doing this, okay, thank you. Agbola said if calculated value is less than the table taken, you take the null hypothesis. Yes, you are right. If the calculated value is is lesser than the table value, you take the null hypothesis. And if the calculated value is greater, you take the alternative hypothesis. Thank you. Olaniyan is asking, please, can you be of assistance for SPSS? The statistical package for social science make all this work easier. But the essence, the reason why we are doing this calculation is for us to value technology. Because if you did not know how to calculate this using manual method, when you make use of the statistical package for social science, it will look as if there's nothing there. Computer can do all these things you are talking about. And at that point, you may not know the value. And that is why we are doing this. So also, I want to tell you that we can be of assistance. Possibly before the end of this month, we'll see how we can show you how we can use a statistical package for social science to run t-test, Hanover, chi-square, and also to do it for any other analysis, be it regression analysis or whatsoever you want to talk about. So you just make sure you subscribe to this channel. You get a video on how to use statistical package to run analysis of any data. So thank you, Agbola. That's set taken. All right. So that's how far we can go. So join me tomorrow, 8 p.m. as we'll be looking at t-test. Join me tomorrow as we'll be looking at t-test. So thank you and God bless you all. So on that note, we want to end it. So let me just